and welcome to this very interesting video on Cadence Virtuoso. So in this video we will be learning about the verification for CMOS inverter using a piecewise linear voltage source. So in practice, the piecewise linear voltage source is often used to approximate more complex waveforms by breaking them down into linear sections. So as you can see here, I have taken a voltage source as V source. So we can give it to any source type like DC source, sine source, pulse source, exponential source or anything. So I am giving the waveform by using a file. So I have written a file for this piecewise linear source. So as you can see, this is a text file, and you can see here it is the location of this text file is within my inverter design. So as you can see, this is the file, this is a text file. So let me show open it to you and let me show what I have written in this text file. So this text file will be used to represent this piecewise linear voltage source. So here I have written this, I have given the location for this file name exactly. So this location should be perfect, otherwise it will give simulation error when you simulate it. So let us see what is the contents of this file. So here we have seen that the first line is 0.0, then again 0.0. So it means that at time interval 0 the value of voltage is 0. Then the next line is 2n 0.0. It means that at the time interval 2 nanosecond the value of voltage source is 0. Then in the next line we can see that the line is written as 4n 0.5. So it means that at the time 4 nanosecond the value of the voltage is 0.5. So in this way we can give the value of the voltage for different segments of time. So let us just run this and let us see the output, and also let us see the voltage waveform. So here I am doing a transient analysis. So let me separate these waveforms. So yes, so this is the waveform. So as you can see, this is a waveform. So it is showing as a triangular waveform, but we can give any shape depending on the values that we have given in the text file. So here this is the input waveform, and again we are getting the output waveform. So the output waveform is little bit square. So that is so we can reduce the distortion by simply changing the length and width of the transistor. So we can change the width of the transistor because obviously the length of the transistors we will keep as constant. So if we change the width of the PMOS and NMOS, then obviously our design will become more ideal. So this is the piecewise linear voltage source. So basically a piecewise linear voltage source is used to represent a voltage source whose value changes in a linear fashion within segments of time. So it is defined by multiple linear segments. So in the next step I have taken I will be taking a piecewise linear voltage source in a different way. So let me just yes, so now I have defined 9 pair of points. So this is VPWL from analog lib library. So as you can see, again for each pair of points I have defined different times and different voltages. So, here we can see that at time 2 the value of time is 2 nanosecond and voltage is 0 volt. Then for the time 3 the value of the time is 2n plus 0.01 picosecond. So that is the rise time. Similarly, for the last we have taken it as 8 nanosecond plus 0.01 picosecond. So for different times I have defined different values of voltages. So I have totally in total I have defined 9 pair of points. So again let us try to simulate with this also. So let us run. So yes, so this is the waveform for the input source. So as you can see, this is a voltage source which is changing with different time segments, and here also the output. So here also the output is a little bit distorted, but again we can make the output more ideal by transistor sizing. So here I just wanted to describe the various voltage sources which are in piecewise linear in nature. So for piecewise linear voltage source we will have to slightly do the transistor sizing. So, and the third voltage source that we can use is obviously a DC pulse voltage source. So that is the most basic source, as you all know already if you have seen my previous videos. So here I have taken a pulse voltage source. So the period of the pulse is 20 nanosecond and the pulse width is 10 nanosecond with a rise and fall time of 100 picosecond. That is defined by me. So again, let us try to simulate the design. So first we will check and save the design. So if you like the video, then please share it with your friends also, and please subscribe the channel. So again, let us try to simulate. So I will load the state, and this is the most basic voltage source, as we can see that. So here also, here the output of our inverter is completely perfect, whereas in the earlier cases there was some distortion. So for the pulse voltage source, we will not see any distortion, because the pulse is the most basic, easiest version of the pulse PWL source. So here again we can see this is the PWL text file. So here we can see that it is changing very fastly, whereas that pulse we have used, it has only got two values and they are also changing very slowly. So that is why